Hey everybody, my name's Catherine, and today on Stay at Home Science, we're going to be answering a really cool question. How do planes stay in the air? Come to think of it, how do planes stay in the air? I mean, let's look at a picture of one. We've got a big plane holding 300 people in it. It has wings like a bird, but it doesn't flap them, so it's not pushing itself up at all. It's not made of feathers. It's really, really heavy. How can a plane stay in the air? Well, the answer to that question isn't as impossible as it seems. The answer is a phenomenon called lift. Now, lift can be explained by something else. Lift is a force which pushes planes upward. And it's explained by pressure. Now, this type of pressure isn't something where somebody's saying, oh, you should go do this, and you're like, wow, I feel pressured into doing that. It has something to do with what air is made up of. Now, crazy enough, air isn't nothing. When I look over here, I don't see anything, but air is made up of a bunch of tiny things called molecules. Now, if we look at this little chart right here, and we look at the gas part, right? A gas is the same as air. Air is a gas. Like when your mom makes spaghetti at dinner, and that smoky stuff comes up, that's a gas. Also, if you were at a bonfire and the smoke is coming up off the fire, that's a gas as well. Now, what gas is made up of looks like this picture. Now, in a solid, liquid, and gas, all of these molecules are arranged differently. First, let's talk about a solid. So, if we look at this little picture right here, we've got a cylinder, and it's holding a bunch of the molecules. Now, these molecules are all arranged together in lines, right? Up and down lines, and the molecules the container's not affecting them at all. The molecules could be sitting in the container, they could be sitting in your table, they would still have the same formation. Now that's what a solid does. A solid is anything super tangible. That means like your kitchen table, your chair, your pencil. It's hard. You can't pour it into a glass. Solids don't take shape of their container. Now, what takes shape of their container? Liquids. Liquids are anything like water, orange juice, or teas, things like that. Now, they take shape of their container. All the molecules are still as close together as they are in a solid, but this time, they all sink to the bottom. Liquids flow, just like gases. Gases are the same as liquids, except they're farther apart and they can float throughout the air. The molecules in a gas just go everywhere. They bang off each other, bang off the walls. They're everywhere in the air. I'm sure I've got hundreds of thousands of molecules hitting me right now, jumping off of me. And the way gas particles move are very important to lift. And it explains what pressure is. So if we think about pressure, you kind of think, it's in the word, you're pressing something. Pressure is when you're pushing someone towards something, or when you're squeezing something, you're putting pressure on it, right? It's the same idea when you talk about it with gas molecules. If you have a higher pressure, that means you're pushing on the gas molecules a lot. If you have a low pressure, that means you're not really pushing on them. They're kind of going wherever they want, doing whatever they want. Now, if we look at these two pictures and pretend that these blue dots are gas molecules, which do you think is a high and a low pressure? If you said that this one was high pressure and this one was low pressure, you're right. Now let's talk about what that means. So we've got this picture right here, and we have a ton of blue dots in this little space. Now if these blue dots are all molecules, you pushed a lot of gas molecules into this little picture. So they're under high pressure. If we look at this picture, we have very few molecules in our little picture, and they're not really being pressed. They have a lot of room to move around. They don't really have to do anything special. They're not going to be hitting into each other a lot. This is low pressure. The thing with gas molecules is they don't like being under high pressure. You know, in this picture, you've got really chill gas molecules. They can do whatever they want, go wherever they want. In this picture, they're all scrunched up into a stuffy room. I mean, think about being in your bedroom, but there's 20 other people in there. You just don't want to be in there. You just want to get out. It's the same thing with gas molecules. So in fact, all these gas molecules are really angry right now, and they just want to get out of the picture. They want to have more room to move around, and they're really pushing up on the walls of the picture, trying to find a way to get out. This is how we explain lift. Now, if you didn't know, this is what an airplane wing looks like. Over top, it's all curved, and over the bottom, it's straight. This means that we've got air molecules which are moving really, really fast over the top, and air molecules which are moving slower down here. This means that we've got like some really chill air molecules running fast, doing whatever they want. And down here, we've got a ton. They're just like, can we just go faster already? I just want to get to the end, but they're moving slow to meet up with their friend at the end. These ones are just moving fast. They're running, they're like, yeah, I'm free, I can do whatever I want. It's so fun. And this causes lift. So down here, all of our air molecules are really angry. They just want to get out. And they're pushing up on the wing. They're like, I'm trying to find a way out. And so when they push up on the wing, the plane goes up. And up here, our molecules are moving fast. They're not pushing up against anything. They don't have a care in the world. Our entire plane gets pushed upward just by a bunch of air molecules. Crazy, right? Things you can't even see. Those are what keeps planes up. All right, well, let's prove it by doing an experiment. This one's pretty easy materials-wise. All you need is a piece of paper and scissors. Now, I have blue-green construction paper, and you don't need anything fancy. You can just get some from your printer. Easy peasy. All right, so the first thing we have to do is go over safety. I know you just want to get to the experiment, so this is really quick. So for this experiment, you're gonna need to use scissors. If you have to ask your parent to use scissors, and if they're not comfortable with you using scissors, then you're gonna have to ask them to sit with you through the experiment and help you cut. Also, just make sure you have a parent around in general so that they make sure you don't get injured with your scissors accident. All right, let's go. The first thing we need to do for the experiment is to make this piece of paper into a square. That means we gotta make all the sides the same length. So the easiest way to do this is to take a corner of your paper and fold it over diagonally like this. And you want this edge to line up with the edge at the top, okay? So once you get that all lined up, you're gonna fold diagonal. Now it doesn't have to be perfect, but it's gotta be pretty good so that your square is close enough to perfect. So after we've got this fold down, we're gonna cut down this line right here while keeping our paper folded so that we don't have any more edge left. Awesome. Now if we unfold, we can see we've got a square. All right. So now actually we're gonna refold that to get a triangle. All right, guys? So this is what our triangle is gonna look like. So you can open it up. After we've made this fold, we're gonna fold it in half again from edge to edge, okay? Boom. So that your 2 corners are touching. Awesome. All right, after this, we're actually going to unfold the fold that we just did. Right, so we're back to our first big triangle, okay? Okay, now the next part can be the trickiest of them all. So I'm gonna do it slow and I'll do it twice at the other frame just to make sure you guys get it. So we've got our big triangle, right? Folds like this, but we've got it unfolded. We're gonna take our 2 bottom corners and fold them up to the tip. Now watch, I'll do it like this for you. So we're gonna pull this corner all the way up to the top, like that. And we'll put it down, smush it down. Awesome. And then we've got one more side. We're gonna take our bottom corner, pull it up to the top, get it in place, put it down, and smush it. So now you've got something that looks like a square, can be unfolded like this. Very cool. Now I'm gonna do it one more time at the other frame, just so that you guys make sure you got it right. So again, guys, we have our big triangle right here, and our focus is to pull our bottom 2 corners up to the top. So first, all right, so we have our kite. That's what our first. Now we're going to move on to the last step. We're going to fold our kite edges back. You've got the type of kite. Now that means we're going to take both of these corners and fold them out. You want to bring this edge right here all the way to the side. Now again, I'm going to do this one twice because it's a bit tricky. So I've got my edge, and I'm going to fold it to this edge. So bring the edge out. Once you've got it out, push it down. And again with the other side, I've got my edge, and I'm going to fold it down, just like this, to the other side. So guys, again, this one I just unfolded, so it's a little bit easier for me to do with one hand. But you're gonna take this center edge, which is normally done like this, and fold it to this outside edge. So look, if we watch this, just push it down, and it makes you a little thing like that, a nice obtuse triangle. We're gonna do the same with the other side. Pull the middle edge to the outside. Awesome. You get something that looks like this. So, you're gonna finish with a frog type looking device. So we have made our device. Now how does this thing explain lift? I'll show you how. So, in order to prove that lift exists, we are going to blow right in here. All right, ready guys? Moved across the surface, right? Now, why did this happen? I'll give you a hint. It has to do with pressure and lift, which we just talked about. Okay, so what happened was when we blew, we sent all the air molecules in our body into this little opening right here, and we created a high pressure system, right? We pushed a bunch of air molecules in here, and they're all in there going crazy. They're like, let me out, I don't want to be stuck in here with all these other air molecules. So they're pushing on all the edges they can find, and they end up pushing on the roof and the sides of our device, so that our device actually lifted off the ground by a little bit, and the forward force that I was blowing pushed it forward. Right? The same thing happens with an airplane. All the air molecules going underneath, they want to get out because it's a high pressure system. And they're pushing on everything they can find, and they push up on the airplane so much that it flies in the air. Alright guys, that's all I have left for you today. Thank you so much for joining me on Stay Home Science. I'm Catherine. Bye!